everyone, a very good evening and welcome back to Sprint 2 of Vedantu. As you know, in this Sprint 2 we have been talking about the previous year question paper of CBSE 2018 class 10, and after that we have started on the second day, that is today, with the board sample paper of 2019 which has been released. You already have watched first part of this paper and this video will be getting the second part to you. And after today we'll meet again on 19th Feb, and on that day we'll be discussing about Vedantu's mock test paper with solutions. And you all know me, this is Dr. Nazma from Vedantu, and now we'll be talking about the second part of CBSE class 10 sample paper of 2019, right? By the way guys, I have watched all your comments on the first two videos which were released 2 days ago, and most of you were asking about extraction of metals and also soaps and detergents. Noted these two topics and we'll get the videos to you as soon as possible. And there we go with our not first question, sixth question of this paper. First five we have completed in the previous video. Let us read the question first. This is a 5-marker and there was an internal choice in this question. A compound A whose formula is C2H4O2. They just have given you the formula and we still do not know the functional group. Please be careful about it. And when this compound A reacts with sodium metal to form a compound B and evolves a gas which burns with pop sound. We do have only one gas which can be identified with the help of pop sound. As you read the question, these all points should flash in your mind. And now moving on, compound A on treatment with an alcohol C in presence of an acid forms a sweet smelling compound D. The only sweet smelling compound that we study in our syllabus is what? Yeah, remember? It is a different functional group and you do it when you react ethanol and ethanoic acid. On addition of NaOH to this sweet smelling compound D, it gives back B and C. So now you have to identify A, B, C and D. You have to write the reactions involved in this particular synopsis. Yeah, there is an internal choice. We'll talk about that later. So let us first solve this first question and then we'll be moving on to the next internal choice wala question. Just for a clearer idea, let me quickly write down the information given in first question in a synopsis manner, in a bullet point manner. You get to see the answers already over there, but then don't focus on them. Focus on how to solve the questions. It's not that the same question is going to appear in the exam, isn't it? You should know the strategy and the steps to solve similar kind of questions, not knowing the answer directly, right? So you're having a compound A and this compound A is reacting with sodium metal Na and it is leading to formation of a compound B along with a gas. And now you are identifying the gas with the help of this pop sound, and the gas has to be what? It has to be hydrogen. Hydrogen is the only gas which can be identified with the help of pop sound experiment. And now the same compound A which is on reaction with an alcohol C lead to formation of a sweet smelling compound D, and this all happens in presence of acidic medium. So acidic medium over here acts as a catalyst, and now this sweet smelling compounds D gives you back B and C. This D gives you back B and C when it is being added to NaOH. When you add the same to NaOH, it will give you B and C. Now you have to identify what is what. So we already know what this gas is. The gas formed over here is hydrogen, and because of the pop sound experiment we have identified. And now what could be A? A on reaction with sodium is giving you B, isn't it? And what is the identification of B? Is there any identification given? No identification as such is being given, but then you can have a guess over here from the molecular formula of the compound C2H4O2. Because it is having O2, according to our syllabus, it could be either acid or it could be either aldehyde or ketone, isn't it? But now, because it is involving in this particular reaction, which is called as esterification, which is giving you a sweet smelling compound D. Anything that involves in esterification, one should be an alcohol and other one should be an acid, isn't it? So one has to be ethanol and other one has to be ethanoic acid according to our syllabus. That's what we have studied, isn't it? So now they already have mentioned that C is alcohol. And if C is the alcohol, what could be A? Molecular formula is here. Please rearrange the same thing into an acid. And how would you do it? You can write it as CH3COOH. And now if you ask me why CH3COOH, why not something else? I'm just trying to rearrange the formula whichever is present here. So according to formula, I can only have 2 carbons which is present in ethanoic acid. So what is A? A is ethanoic acid. And then which alcohol could this be? We'll talk about it, but before that, let us once more cross verify if this is alcohol or not. You have to check with this first equation. Alcohol on reaction with sodium, will it give you H2 gas? Yes, it will give you H2 gas. It will undergo a single displacement, isn't it? Sodium displaces hydrogen of alcohol, leads to formation of a salt along with hydrogen gas. So yes, we are sure that C is nothing but alcohol. But which alcohol could this be? Could this be ethanol or methanol or which alcohol? It could be anything, isn't it? But then look at the continuation. When you take this ester whichever is being formed and hydrolyze it in presence of NaOH, it gives you back B and C. Yeah. So what is C? C is the alcohol that you are getting. And what is B over here? B is nothing but CH3COONA. How do I know this is CH3COONA? When A is already been identified as an acid, then what could be? As a result of reaction between Na and acid, what could have been the product obtained? It would just have been CH3COONA. So ultimately A is acetic acid, or you can also call as ethanoic acid CH3COOH, and B is CH3COONA, which is nothing but a salt of sodium. We call it as sodium acetate or sodium ethanoate, followed by C, alcohol, and ultimately D, the ester which is being formed over here, CH3COOC2H5. And these are A, B, C, D which have been identified. So whenever you deal with this type of questions, you have to keep cross verifying in order to ensure that whatever you are writing is correct. Yeah, I quickly repeat, why did we do this? A is nothing but an alcohol because it is undergoing, A is nothing but an acid because it is undergoing a reaction with sodium and leading to formation of B along with gas. So you can suspect A to be either alcohol or acid, but then from formula it is CH3COOH. Yeah, and now what could be this gas? Hydrogen. And what is this B? The product has to be CH3COONA if these two are the reactants. Now you're taking same A along with C, which is an alcohol, and you're conducting a reaction in acidic medium which is called as esterification, leads to formation of a sweet smelling agent called as ester. And one more thing, there will be a byproduct obtained here as well, which is water. And now these two, when are reacted with a few drops of aqueous NaOH, will give you back B and C. B and C which are obtained over here are nothing but B and C which are obtained over here are nothing but one CH3COONA and C2H5OH. Yes, are we clear? And we already have mentioned the equations over here as you get to see on the screen. Done. So good to go with the second part of the question, which is internal choice of the question, not second part, right? So let us once read the question and then come back to the answer. Done. There are two parts in this. Both of them together carries 5 marks and we'll have the marks split later. Let's read the question first. Explain why carbon forms covalent bond. The reason behind formation of covalent bond by carbon. Give 2 reasons for carbon forming a large number of compounds. We know, right? Carbon is the king of elements and it is very versatile. It forms so many compounds, which is estimated to be approximately 5 million and above. Now, second part of the same question, explain the formation of ammonia molecule. So they have not mentioned how. Sometimes they might mention as explain it with the help of Lewis electron dot structures. Now, since it is not specified, you can use any method to explain, either Lewis or the geometrical representations that we discussed in the last video. Done. So let us begin with the first part, why carbon forms covalent bond. First of all, what is covalent bond? A bond which is formed due to mutual or equal sharing of electrons is called as covalent bond. Correct? And now, why carbon is forming covalent bond? Why something will form covalent bond? Like, what are the conditions to be satisfied when you want something to form covalent bond? 1. It has to be non-metal. 2. The counterpart or the other element which is involving in bonding also should be a non-metal. Yeah. So now let's look at the reason why is carbon forming or carbon preferring to form this so and so covalent bond wala concept. According to its electronic configuration, carbon's valency is 4. And anything with valency 4 will not tend to lose electrons or will not tend to gain electrons because both are at the same distance, right? But other than doing that, they prefer sharing electrons because of its tetravalency. It cannot form C-4 easily, and at the same time it cannot also form C+4 easily. It doesn't mean that it cannot at all form. It can form, but when you compare with this loss or gain of electrons and sharing electrons, sharing is more feasible according to energy relations. So because of these two problems, that it is not able to form C+4 or C-4 easily, it will be tending to share electrons, as a result of which it leads to formation of covalent bonds or covalent compounds. But we also have one or two such cases where carbon has formed C-4 also. You will learn about that in class 12, but then this is the usual case. Because of tetravalency, carbon does not prefer to turn into C+4 or C-4, but it will be sharing its electrons, correct? And now sharing of electrons leads to covalent bond only. Next one, the next part of the question, what are the reasons behind carbon or behind some element being able to form so many compounds? We have some elements in the periodic table, like first one is carbon, but other than carbon there are some more elements, like we have silicon, we have oxygen, which can form majority of the compounds. What could be the reason or what are the feasible conditions for something to form more number of bonds? 1, it should be able to form more number of bonds which are strong and stable, and second one, it should also be having a capacity to link with any type of atom irrespective of its nature, and it also should have that self-linking capacity. Both of these concepts put together in a shorter way, you call it as catenation, self-linking capacity. Carbon can link with infinity number of carbons. It can link with 100, 200, any number of carbons, and we call this phenomenon as catenation. Carbon is the highest catenating element in the periodic table. And the second one is tetravalency. We spoke about it already. So tetravalency, having 4 electrons in the last shell and requiring 4 electrons to satisfy valency. But then why is carbon the most versatile? Why not some other element? I said silicon also can form. If you look at position of silicon, even that has tetravalency. Even that is belonging to the same group that carbon belongs to. Then why is carbon highly catenating, or why is carbon highly versatile? Because carbon has high electronegativity, which makes its atomic size lesser. Because of this lesser atomic size, what happens is carbon will be able to maintain its bonds which are formed strongly. and according to the position in the periodic table, silicon is bigger, and silicon cannot have that high electronegativity, with the help of which it can hold the shared pair of electrons strongly. So one more reason that if had to be added, it would be high electronegativity and low atomic size are the reasons behind this versatility of carbon, and are the reasons behind this carbon being the king of elements, right? Now, second B part of the same question, formation of ammonia. Before you could display or you demonstrate the formation of any molecule, identify which type of molecule it is. Ammonia, covalent or ionic? It is covalent. How do you know? When you have two metals combining with each other, it would be a metallic bond. If you have two non-metals in bonding with each other, it will be a covalent, like this, nitrogen, hydrogen, non-metals. And if you're having one metal and non-metal, then it will be ionic bond. Yeah, so now because it's covalent bond here, you have to show sharing of electrons. Yeah, and if you are talking about ionic bond, then you would be showing the donation or transfer of electrons, and you will use the symbols of like arrow mark in case of ionic bond. But right now we are talking about covalent, isn't it? So we'll be using this sharing wala symbol. Hydrogen, originally it has one electron, right? And according to electron dot structures, I'm representing only valence electron of nitrogen as well. 1, nitrogen 2, nitrogen 3, nitrogen 4, nitrogen 5. It has 5 valence electrons, correct? But then to attain octet configuration, it just needs 3 more electrons, so that totally its configuration becomes 8. Valency of nitrogen is 3. So only 3 electrons will be involving in bonding. Now how will they involve in bonding? They'll be sharing electrons with hydrogen. So there you go, first electron shared with first hydrogen. Look at hydrogen, it has got duplet and it has attained stability, so it will not be interested anymore to share next electrons. But now nitrogen doesn't have enough. It has 5 electrons in the last shell of its own, now 1 electron for sharing, so totally 6. It needs 2 more, so it will be sharing 2 more electrons with hydrogens, with 2 hydrogens more, as a result of which it will be having octet configuration. But you have to observe something over here. Nitrogen shares only 3 pairs of electrons, and 1 pair of electrons remains as it is in the valency shell. They don't involve in chemical bonding. You call that as lone pair, but you don't need to learn it now, just for your information. So this is how covalent bond is formed between nitrogen and 3 hydrogen atoms. So nitrogen ultimately will be sharing electrons, and these are the electrons of inner shells of nitrogen, which are stable and which don't interfere in chemical bonding and all of that. This is how we got to represent bonding in nitrogen. So the same thing is explained. Try to explain the same thing in 2 points, because the entire question, the part 1, part A and part B, is for 5 marks, isn't it? So this 5 marks is split as 1 mark, 1 mark and 3 marks for explanation of this particular question. So if that is the case, you would have to explain it. Now, shall we move on to next one? These are the practical based questions. As you all know, we have practical based questions every year. Last year we have had 2 chemistry practical based questions in boards, and even this year we are expecting the same. There are some practical based questions that we are going to discuss, and in our second video of sprint 2 I also gave you some info about how kind of practical based questions will come. So please don't ignore it, and this is one area that you have to focus on, because you have rest everything in textbook, right? Practical based questions is something which depends upon your analysis, so you would have to focus on it. You have scope of losing marks over there. If you focus and if you learn, you can also score full marks here. Anyways, let us read the question. When few drops of phenolphthalein, what is phenolphthalein, guys? It's a chemical, but then it acts as acid base indicator, isn't it? And now when few drops of phenolphthalein is added to a dilute solution of sodium hydroxide, a pink color is being produced. What will be the color of the final mixture when excess of HCl, note this point, you're talking about excess of HCl which is being added. Justify your answer. So there is second part, which is internal choice question. We'll talk about it it in a while, but before that let's finish this question. They're talking about an acid base indicator by name phenolphthalein, which is being first added to sodium hydroxide. So NaOH in presence of phenolphthalein is giving you a pink color. So what is the color of phenolphthalein in basic medium? It's obviously pink. And now to the same solution, what are you doing? You're adding excess of HCl. So now what will be the pH value, or what will be the nature of that excess of solution? I mean the nature of the final resultant solution. Because you're adding excess of HCl, ultimately your solution is turning acidic, isn't it? So if you have added excess of base, it would remain base. So now because of that excess of acid, you are having the final mixture turned into acidic. And now because the final mixture is turned into acidic character, the color of phenolphthalein in acidic character, as it is colorless, you get to see the colorless solution being noticed. The color transformation happens from pink to colorless. Since it is observation, you have to talk about colors. Don't talk about, neutralization happening and all of that. Not required. Observations are all about colors of anything, precipitate, residue, gas, solution or whatever. And 2 could be about heat liberation, evolution of gas. So here you will get to see pink to colorless because the solution have turned acidic. Color of phenolphthalein in acidic is colorless. Moving on, the next question. Arrange the metals iron, magnesium, zinc, copper in increasing order of their reactivity. What will be the 2 observations made by the student when iron filings are added to copper sulfate? So it's a very easy question. We all know reactivity series very well. In sprint 1, I also gave you a mnemonic to remember this reactivity series, correct? So reactivity series also falls into first 3 chapters, and I'm sure everyone's confident about it. We got to arrange all these 4 elements according to the order of reactivity series, but then observe which order. The talking about increasing order, you got to start with the least reactive. Of course, copper is least reactive, so I'm giving you first place. I'm giving copper the first place in our increasing order of reactivity, followed by iron comes next, followed by zinc comes next, and finally magnesium. Magnesium is more reactive when you compare with rest of them. And now first part is over, that's 1 mark, and second mark is the observation when you add iron filings or iron nails to copper sulfate solution. This is the classical equation of our syllabus. Study it so many times. Blue colored copper sulfate solution, when you are placing iron nails, iron filings, anything of iron into this blue colored copper sulfate solution, because copper is less reactive, the displacement happens. What is the displacement? Just for your knowledge, not knowledge, just for the sake of recalling, I'm using this here. You don't need to write the equation as a part of the solution because they didn't ask you. Iron occupies the place of copper, leads to formation of iron sulfate, and along with that you will be having copper. So this iron sulfate's color is green, so you will get to see the color of the solution changing to green. To be specific, you can write it as pale green. It changes to pale green. Moving on, other than that, what could be the other observation? You also will observe copper being deposited on iron nails, and now the copper's color is reddish brown. So reddish brown deposition occurs on iron nails. In this question they are talking about iron filings, so mention it as iron filings. Only 2 things. Are we clear? These are the 2 observations that we can make when so and so reaction, single displacement reaction, is happening between copper sulfate and iron. Now also remember, it's a irreversible reaction. You can't reverse it. If you are taking iron sulfate and copper, what do you think will happen? Nothing will happen, because iron is more reactive and it does not let copper occupy its position. So this is a practical based question with internal choice, and now we are moving on to the next question. Take a look at this. Even this is a practical based question, 2 marker, and let us read the question. From an experiment to study the properties of acetic acid. Acetic acid formula. I'm asking you, acetic acid formula. Acetic acid is a common name. It's present in vinegar. It's an organic acid, and the formula is CH3COOH. It might not be needed for the solution. I'm just trying to revise other topics also with the help of this question. Answer the following questions with respect to this statement given. Name the substances which, on addition to acetic acid, produce carbon dioxide. You have acetic acid. You have to name one such substance which can produce CO2, isn't it? Yeah, carbon dioxide when treated with acetic acid. Fine. And you also have to write the chemical equation for this particular reaction. Second part of the question, how is CO2 gas tested in laboratory? Very interesting question. So let's begin with the first one. We are talking about how do we get to know? How do we get to know which substance will give you CO2 on reaction with acetic acid? This is also, the same reaction is also a part of that one question which is most important. And you know which question is that? How do you differentiate chemically between ethanol and ethanoic acid? Remember, sprint 1. So if you are having ethanol, sodium carbonate, bicarbonate, do not react with it. But if you are having ethanoic acid, sodium carbonate or sodium bicarbonate react spontaneously with ethanoic acid, giving you a effervescence or a fizz of carbon dioxide. Use the same reaction, same equation will work. Sodium bicarbonate, formula NaHCO3. And now this is the equation. How do I know how to write the product? Again, the tactics that we used in sprint 1, double displacement. If you have two types of cations and two types of anions, just have to mutually exchange their places. Do the same. It leads to formation of CH3COONA, which is nothing but sodium acetate. Its common name, sodium acetate is common name. Learn IUPAC names. It's called as sodium ethanoate. Okay. And now you will be getting H2CO3 as a double displaced product. But then H2CO3 doesn't exist at room temperature. It immediately dissociates. So you will write it as HO2 and CO2. That's it. So sodium bicarbonate is the answer for first part of the question. Let me also ask you one relevant question to this. What is the common name of sodium bicarbonate? Is it called as washing soda or baking soda? It's called as baking soda. It's not baking powder, it is baking soda. What is the difference between both of them? Baking powder has a mixture of sodium bicarbonate and tartaric acid, but this is baking soda. Done? Okay, let's move on to next one. CO2 can be tested in many ways, but one among them is with the help of lime water. CO2, when passed through calcium hydroxide lime water solution, it turns lime water milky. The most classical equation of our syllabus again. Let me also write the chemical equation because it itself could be an independent 1 marker or sometimes also could be a 2 marker, like when it is asked with the help of some other question. You are having CaOH twice. Do remember, you call this as lime water only when it is in aqueous physical state. Okay, otherwise it's usually solid at room temperature, and now you are reacting with CO2. It leads to formation of CaCO3 along with water, but then the thing is CaCO3 is a precipitate. It's a white colored precipitate because it is present along with water, and precipitates are insoluble in water. It creates that curdy look. We call it as milkiness. So white colored precipitate calcium carbonate is formed, which turns lime water milky. The reason behind milkiness of lime water is this CaCO3 formation. And one more important thing here to be noted is this is when you are using limited or sufficient CO2. After formation of this lime water, after formation of this milkiness or precipitate also, if you pass excess of carbon dioxide, what happens? Any guess? When you pass excess of carbon dioxide, it leads to formation of calcium bicarbonate, CaHCO3 twice, which is water soluble and which will turn the solution back into colorless. So on passage of limited carbon dioxide, lime water turns milky, but then on passage of excess carbon dioxide, you will have the milky water turned back into colorless solution. Important thing. Done. So this is actual practical based question. This just I have extended because this is also enough important. Done. So these were some questions that I wanted to discuss. I hope you have taken snapshot or noted down these equations. Yeah. So yeah, these were some practical based questions, and also we have completed discussion of all the chemistry questions which have been asked in 2019 sample paper. This is not previous year paper, this is just a sample paper, but then guys, sample papers are equally important. This will give you an idea about the type of questions that might come in this year examination, right? So as usual, let me know what topics or what questions do you have in our syllabus, what more do you need, so that you don't even lose one single mark in chemistry of your board exams, so that we can help you out from Vedantu. And I already noted that soaps and detergents and cleansing action, you will get a notification about the videos. You will get some sort of help to understand those topics soon. So don't forget to let me know your pain points in the comment section of this video. And also, as you know, according to the timetable, in the next video that we are meeting on Tuesday on 19th of Feb, we'll be talking about the mock paper which is conducted by Vedantu. We'll discuss the mock test exam paper which is conducted by Vedantu. Done. So until then, please prepare very well. Ask all your questions in the comment sections. Make use of Vedantu YouTube channel, which is trying to serve all the students who are genuine and seriously aspiring to secure good marks in 10th boards. Subscribe to Vedantu Class 10 channel. I'll see you all in the next video. Until then, keep learning. Don't waste your time. Work hard so that you don't regret after your exams or results. Done. Good luck everyone. Bye bye.